Okay, welcome. This is now case 3 of electric flux through a cube using the solid angle. Okay, so again, I am considering here a cube. Now the charge is placed at the face center of the cube. So this is our cube. I have placed the charge at the face center. Now we have to find what is the flux through each face of the cube. So first of all, we will use the usual method, that is what is the flux through the cube. So for that case, the total flux is equal to charge enclosed divided by epsilon naught by Gauss's theorem. So that is equal to charge enclosed is Q divided by 2 because we need two cubes here to enclose the charge completely. So contribution of the charge in this cube is only half, that is Q by 2. So then flux is equal to Q divided by 2 epsilon naught. But is the flux through each face of the cube equal to the total flux divided by 5? So can we write flux through each face is equal to flux total divided by 5? No, this is not the case. So it is not equal to Q divided by 5 into 2 epsilon naught. That means the flux through each face is not equal to 1 by 5th of the total flux, that is Q divided by 10 epsilon naught. Why? Because all the faces are not symmetric with respect to their charge. If we look at this face, that is ABCD, the charge is on the axis of this face, that is the foot of the perpendicular from this charge is the midpoint of this face, whereas other four faces are symmetric. The other four faces are symmetric because the charge is symmetric with respect to this face, with respect to the back face, with respect to this front face and the bottom face, right? So the charge is at a distance of h by 2 from the midpoint of each edge. So it is symmetric with respect to each face. So that means the flux through other four faces will be same. Now, let's see first what is the solid angle subtended by this face ABCD so that we can calculate flux through this. The solid angle subtended by ABCD at the charge is 4 sine inverse LB divided by under root of L square plus 4H square times B square plus 4H square, where we consider this as a rectangle and the charge is at a distance of H from the midpoint of the rectangle, right? Now, in case of the cube, we have L is equal to B is equal to H is equal to A, say. So then using A for all the parameters L, B and H, what we get? The solid angle subtended is 4 sine inverse. So this is A square divided by 5A square. So that comes out to be 4 sine inverse 1 by 5. We have calculated the solid angle subtended by this face ABCD, that is directly opposite to the charge. Now let's see what is the solid angle subtended by other four faces. So let me consider one face because the solid angle subtended by other four faces, other three faces will be the same as that of this face. So I am considering the bottom face, that is AB, then it is FE, this is AB, FE. Now the charge is at the center of this face, that means at a distance of h by 2 from the midpoint of this edge, right? So I have put it here, charge here. Now before that, I take this line here at a distance of h because we know the solid angle subtended by this face or this surface at this point, that is when the foot of the perpendicular lies at the corner of a square or a rectangle. Now if we consider this as a rectangle such that this is L and this is B and this is H, then solid angle subtended at point P by this rectangular surface at point P, which is perpendicular, whose foot of perpendicular lies at the corner of one of the corners of the rectangle. So solid angle subtended at this point is sine inverse LB divided by L square plus H square times B square plus it is H square, right? Now, If I shift this point P to point P dash, that means now it is perpendicular to the mid of this edge, that is FE, right? Okay, so when it is perpendicular to the mid of the edge, this FE, so that means I am making it two rectangles of L by 2 and L by 2 length, and the breadth remains same. So we can use again the same formula here, but instead of L we have to use L by 2. So that means the solid angle subtended by then these two rectangles, that is again the this rectangular face, but now the foot of the perpendicular is on the midpoint of the edge. So then omega P dash is equal to 2 times the solid angle subtended by one part. So that is sine inverse L by 2, then it is B divided by, it is L square by 4 plus H square times B square plus H square, because I have taken here L by 2. Now, if I again shift this point P to point Q where the charge actually lies, so what I have to do, P shifts to Q, so that means now H is reducing to H by 2. So instead of using H in this, I will use H by 2. So the solid angle subtended at point Q, that is where the charge lies, which is actually the face center here. So it is 2 sine inverse, it is L by 2B, then divided by under root of L square by 4 plus H square by 4, then it is B square plus it is H square by 4, right? So that means the solid angle subtended by this face at point Q, that is solid angle at point Q where the charge actually lies, by this face is equal to sine inverse. Now since this is a square face actually, so we can take this L is equal to A, B is equal to A, and this H is now A by 2. Using all these things here, so what we get, it is 2 sine inverse A square by 2, then it is under root of 10 A square by 4, so that comes out to be 2 sine inverse 2 divided by under root of 10. So solid angle subtended by the bottom face and the top face, the back face and the front face is same. So we can now calculate what is the flux due to through this cube due to this charge Q. So the total flux is the flux through this ABCD, which is directly opposite to the charge, plus 4 times the flux through this type of face, that is this face, top face, the front face and the back face, because they are symmetric with respect to the charge. So that is why I am writing here 4 times. Okay. So then phi total is Q divided by epsilon naught. Then it is omega, the usual formula, total the solid angle subtended divided by 4 pi. So solid angle subtended by all these faces omega ABCD plus 4 times omega ABFE divided by 4 pi, right? Now here 4 and 4 cancels when we divide it by 4 pi. So it is sine inverse 1 by 5 that we have already calculated here. So it is sine inverse 1 by 5. Then plus 4 times this is 2 sine inverse 2 divided by root 10. Now 4 pi divided by. So cancelling here 4 and 4, we get Q divided by this epsilon taking this pi taking out. So it is pi epsilon naught sine inverse 1 by 5. Then plus 2 sine inverse 2 divided by root 10. Now when we substitute the values of these sine inverse 1 by 5 and sine inverse 2 divided by 10, it comes out to be 0.2013 plus, now it is 2, then it is multiplied by 0.6847 up to 4 places of decimal, then dividing it by the value of the pi, so that is 3.14. So what we get 0.5 up to 1 place of decimal. So then it is phi t equal to Q divided by, it is 2 because 0.5 is 1 by 2 in terms of fraction. So it is Q divided by 2 epsilon naught. So that is exactly what we calculate here, that is total flux. Now the question is, if the value comes out to be here Q divided by 2 epsilon naught, and I have verified it Q divided by 2 epsilon naught. So what is fun of doing all this mathematics? The fun of doing all this mathematics is, when we do these types of problem, we skip the flux through these phases because we don't know how to calculate it. They are not symmetric. So now with the help of solid angle, we can calculate what is flux through the front phase, that is directly opposite to the charge, and what is flux through other four faces which are symmetric with respect to the charge. So the flux through each face can now be calculated, because we know here flux through each face, here flux through the front face. So this way we can calculate what is flux through each face of the cube.